Nice. Okay, so good evening to everyone. The first thing that I'm going to do is to put the problems on the board. Some of the problems that we're going to be taking a look at. Nice. Good afternoon, everyone, or good evening. It's dark outside already, so I'm ready to say good evening, everyone. Welcome all. We have new followers and we have the veterans who have been with us from the beginning. Thank you for joining. Thank you for sharing. Thank you for telling others. And we have just, as a matter of fact, though that we have started already, so some individuals might not be good evening. So I'm saying that too. Is that TJ God? That's a nice name. Yes. God is one of the original names for one of the tribes of the children of Israel. There you go, just for those who didn't know. That one was Gad, Dan, Asher, Naphtali, Simeon, Levi, Judah, Benjamin, Joseph. Who have the early one I didn't mention? Simeon, right. So 12 of them, I don't have all of the names in my head right now, but we know that God, G-A-D, God is a great name. One of the names of the original tribes of the children of Israel. All right, so we're about to solve linear equations, right? We're about to solve linear equations. I think that we are just right about on the edge of time. So if we begin, we'll be beginning at exactly 6 o'clock. Right, so we are near there, and we're about to solve linear equations, students. You need to understand that mathematics is a very diverse subject. And a lot of the other subjects that you are taught, like principles of accounts, economics, probably all of physics, physical chemistry, and a good portion of your inorganic. We have to do your titration, working with the mole concept. All of those principles of accounts, all of those are applied mathematics. Technical drawing also is applied mathematics. Art is such a part of mathematics that the early artists, the early painters and sculptors, they used to use a lot of mathematics, proportions, and formulae when they do their painting, and that is why some of those beauties that they have created, how many years, how many hundreds of years now, they are not being repeated because we are not privy now to the knowledge that they had of mathematics. So they know that if they're going to draw a human body, that across here must be in certain proportion to this. They know that. They know that around here must be in proportion to around your waist, and that from the top of your head to your navel should be in a certain proportion from your navel to the ground. So they know that. And there are certain things that people look at when they are looking at beauty, like symmetry. Your face should be as close as possible to being symmetrical for you to be considered beautiful. So that's mathematics. Also, in the international beauty contest, whether it is Miss Universe or Miss World, whether it is a modeling international contest or an out-and-out beauty contest, you will see that the majority of ladies who would have won those competitions are very, very close to 5 feet 8 inches tall. Surely not shorter. The shorter ones will win, but that's a rarity. The ones who are 5 feet 8 and close to that, those are the ones who generally win. So there's mathematics in everything that they consider on the face of the earth. And your arguments in the Department of Language and Linguistics are mathematical models. Alright, so even if you are in the area of language and linguistics, you will not do as well, you will not excel to the extent that you should if you are not excellent at some area of mathematics. So mathematics is greatly applied to almost everything in life. Now, you are here and about to solve linear equations. I will not teach you how to solve a linear equation. We are going to go to quadratic equation after this, if we are finished in the evening, and I will not teach you how to solve a quadratic equation. Then when we go to simultaneous equation, I will not teach you how to solve simultaneous equations. So there's hardly anything that I will teach in the book of algebra now. Why? Because as I said before, you need to know how to factorize, you need to know how to manipulate directed numbers, and you need to know how to transpose a formula. And that's more than half of your life in mathematics. Of course, the other algebraic stuff will matter, indices, dividing, multiplying, and all of those things. Yes, but they are secondary. The major things, you must know how to manipulate directed numbers, positive and negative numbers. You must know how to factorize. You must know how to transpose a formula. We did transposition of formula recently, and now we are going to solve an equation. Solving an equation is also transposing a formula, and that is why I don't need to teach you how to solve an equation. And I'm not going to teach you how to solve an equation. We are just going to apply Yes, I'm only going to teach you how to apply whatsoever we are applying. So you're just going to apply the concepts that you learn in transposition right here and now, because you know how to solve an equation already, because it's the same exact thing. Except that because in the equation that you're going to be solving, there's only one unknown, so the transposition is easier. It should be simpler. Let's go. The first thing that you need to do is what? Isolate x. X is accompanied by 3. By what? How is x accompanied by 3? By addition. That's a one-step problem. 3 is added to x. How do we eliminate the 3 right there? 3 is added. How do we eliminate the 3 that is added? Alright, since you are not ready with your twiddle fingers as yet. The 3 is added to the x. We need to eliminate that 3 that is added. And we're going to do the opposite of addition, which is subtraction. So we are going to subtract 3 right there in order to eliminate this 3. And in order to balance the equation, we're going to subtract 3 here. So we're going to subtract 3 from both sides. When we subtract 3 from the left-hand side, all that will be left is x. And when we subtract 3 from the right-hand side, we will have 9 minus 3, which is 6. And we are done. The next one, 3q is equal to 12. 3q is equal to 12. What do we do with that one? How do we eliminate the 3 that is associated with the q right there? What do we do? 3q, what does 3q mean? 3q means that q is being multiplied by 3. Because it's being multiplied by 3, we need to eliminate that 3. How do we eliminate that 3 that is being multiplied? Divide by 3 on both sides. So that's what we're going to do. Why we do it on both sides? We divide by 3 in order to eliminate the 3 from this side so that we'll have q alone. And we divide by 3 on the right-hand side in order to balance the equation. 12 divided by 3 is equal to 4, and we are done. Let's see what we make of the next one. R plus 7 is equal to 4. Let me see if there's anyone else who is experiencing below 0 degrees Celsius temperature. We are going to do that by subtraction. So we are going to eliminate the 7 by subtraction, and we are going to subtract 7 from both sides. I will tell you what will happen when you subtract 7 from the left-hand side. When you subtract 7 from the left-hand side, the 7 will be eliminated. And when you subtract 7 from the right-hand side, what is the result? What will be the result of subtracting 7 from the right-hand side? What will be the result of subtracting 7 from the right-hand side? Yes, so we'll have 4 minus 7, and that is negative 3. And that is what I spoke about just now, that you need negative 3. That is why I spoke about now that you need to know how to manipulate your directed numbers. Immediately, we have it right there. Now, number 7. M divided by 5 is equal to 8. M divided by 5 is equal to 8. What do we do? Now, we are surely dividing by 5 there. So anybody will tell, multiply by 5. Exactly. Because we are dividing by 5 here, in order to eliminate the 5 that we are dividing by, we do the opposite of division, which is multiplication. So we'll multiply by 5. On the left-hand side, in order to eliminate the 5. On the right-hand side, we will also multiply by 5 in order to balance the equation. And when we do that, we'll have what? M on the left-hand side, and of course, 5 times 8 is 40. No problem. Now, we're going to go up a notch. Now we are going to, sorry. No, this is, you know that we don't do tutorial question on a Monday. Monday is an instructional class. So I will not be working from the tutorial book on a Monday without telling you. We'll do it on a Monday, but we're not just going to do it just off the top of our heads like that. What I'm doing now for the linear equations, you have hundreds of problems to solve as it pertains to working with linear equations. So what I've done, I've gone to your instructional manual and I've taken out the most general exercise. And the most general exercise is your homework exercise. So for the solution of linear equations, which is topic number 6, solution of linear equations, I'm gone all the way to the homework section because it has the most general set of problems to solve. Because what we are doing now is merely classwork. That's what we are doing. And of course, we do not need to study how to solve the equation. We just need to solve the equations because the principle that we are going to be using is the same exact principle of transposition. That's what we are using. Right, so we are using the principles of transposition. Go to your instructional manual and go to the homework section in topic number 6, solution of linear equations. Okay. All right, so let's continue. All right. For this one, now we have 7x plus 2 is equal to 16. So we need to eliminate the 2 and we need to eliminate the 7. What do we do first? Which one do we eliminate first? Which one do we eliminate first? I'm giving you a shot at it. We eliminate the 2. Eliminate the 2 because the 2 is the one that is least related to the proposed subject. So we will eliminate this 2 first. And of course you can see that we're adding 2 here. So we'll eliminate 2 by subtraction. Subtracting 2 from both sides because we cannot subtract 2 from one side alone. Subtract it from the left hand side in order to eliminate the 2. And on the right hand side, we will subtract 2 in order to balance the equation. So what we will have there is 7x is equal to 14. 7x is equal to 14. And then x is equal to, and you will tell me what x is equal to in a second. 7x means 7 times x. The 7 is related to the x by multiplication. Yeah, there it is. We're going to eliminate the 2 by subtraction. So we go to the 7 now. You're not at the 7 yet, but I am at the 7, so I'm giving you some time to do. We divide by 7, yes. Give you some time to get there. So since we are multiplying by 7, on the left-hand side, that is the proposed subject, or what we call the unknown, is being multiplied by 7 there. In order to eliminate it, we need to divide by 7, and then divide by 7 on the other side also, in order to keep your equation balanced. So we'll have 14 divided by 7, and that will give you your 2. Notice that I am not including intermediate steps. Also, in the transposition, I was not including intermediate steps either. Of course, for the first demonstration, which is, of course, the greater instructional part of it, we had about 7 or 8 problems to solve, and those problems were solved by, well, the earlier few by putting in the intermediate steps. And then when we get the gist of it, we moved on, not including the intermediate step. And the students who have been here, like my loyalists, you know that when we are solving an equation or transposing a formula, nothing changes side. So there's nothing that goes over the equal sign. Nothing goes over the equal sign. We know that. And also we know that nothing changes sign. There's no change of sign. And there's no change of side either. All right. Great. Yes, everything is done on both sides. This one, number 11. Let us move merrily to number 11. What do we say about that? We need to eliminate the 7. We need to eliminate the 5. Right, so we need to eliminate the 7 and we need to eliminate the 5. And of course, we can solve by analogy, where here we eliminated the 2 first because it was least related to the proposed subject. We are going to do the same here. Eliminating the 7. Okay, I was looking for some assistance from the chat, but not yet. Which I know in a minute or two we'll have that going. All right, so let's go. We will eliminate first. What do we eliminate first? I'm going to give it, okay, we eliminate this 7. And we're going to eliminate this 7 by addition. So we're going to add 7 to both sides. When we add 7 to the left-hand side, the negative 7 will be eliminated, so we'll just have 5q there. And of course, we're going to add 7 on this side also, so we'll have 25. And finally, we will eliminate the 5 that is accompanying q right there. And what do we say? All right. Yeah. Students, the reason for you saying we subtract 7 from both sides is because you're not putting yourself through the process. You're just glancing and doing. You need to put it through a process in your mind. For example, if you look at the problem and say, all right, 5q is equal to 7. 5q minus 7 is equal to 18. We will eliminate the negative 7. If you say to yourself, I am going to eliminate the minus 7, you would not put back minus 7 because you know that you have to eliminate the minus 7. So you cannot skim the top of it, students. You have to internalize the problem. No matter how short a time, yes, no matter how short a time, you still have to You still have to internalize the problem. Yeah. So let's continue. Of course, we say that we should eventually divide by 5 on both sides. I think that is, yes, yeah, by 5 on both sides. Exactly. So when we divide by that, we get what? 5 there. 5, 25 divided by 5. So let us move merrily to number 13. What do we say? We have 3v plus 20 is equal to 5. 3v plus 20 is equal to 5. What do we do? What do we say? Process it. 3v plus 20 is equal to 5. The first thing that we need to eliminate is this 20 that is added. As long as you say that we need to eliminate the 20 that is added, you are going to say the right thing. First minus 20. So we'll subtract 20 from both sides. From the left hand side, it is eliminated. From the right hand side, give me the result on the right hand side, please. When we subtract 20 on the right hand side, what will be the result? Negative 15, because it's going to be 5 minus 20, that's negative 15. And finally, what do we do? So we are going to divide by 3. Right. And negative 15 divided by 3 is negative 5. Beautiful. So students, notice what we are doing. We have started off in a certain manner, and by the time we get to number 17, as a matter of fact, by the time we got to number 9, we would have changed the gear. Thanks. On both sides. Alright, so let's continue down to here. Because students are skillful manipulating directed numbers, then this problem should not be difficult. The person who is asking what topic we are on, do you have an instructional manual? Okay, that's fine. Let's continue. When I say if you have an instructional manual, this is what I mean. Oh, putting up into the wrong camera. As long as you have this book, then you are okay. Alright, so let's continue. Alright, so we are at number 15. Let's see what you make of it. We are making x the subject of the formula. What do we do first? We are making x the subject of the formula. That means we are solving this equation for x. What is our first move? Anybody with a suggestion? Add 15. On both sides. The person who is saying add 15 on both sides, could you give me a reason? Give me a reason why you'd add 15 to both sides. After you Who's saying that we should minus? Let the person who said that we should add the 15 tell us first why. And then you tell us next why we would subtract. That's nice, man. Once they divide by 9. Okay. Why should we add 15 to both sides? All right, the one who said that we should subtract 15, tell us why we should subtract 15. Oh, say we need to subtract 15 because the 15 is positive, for sure. So this is a positive 15, so we will eliminate this positive 15 by subtracting 15. And of course, we will do the same thing on the other side. So subtract 15 from both sides. So let's go. When we subtract 15 from the left-hand side, the 15 will be eliminated. So, but I'm going to be waiting for you also to tell me what is going to be on the left-hand side and what is going to be on the right-hand side. Let's go. Yes, we're in the process of doing that. We're subtracting 15 from both sides. What will be the result on the left-hand side? What will remain on the left-hand side when we subtract 15 from the left-hand side? The screen is blank. I know that you will have some internet difficulties. Maybe I will have some also, because we have a negative 9x is perfect. Negative 9x is perfect. And let me see the other result. We have negative 9x. What else? What will be on the right-hand side? But just let me know what is going to be on the right-hand side. Let's go. A negative 12. Negative 3 minus 15. Negative 18, 12, negative 12, 12, negative 18. This one. So x is equal to, what's the value of x finally? What's the value of x finally? Two, negative divided by negative is positive. So we are multiplying by a negative 9 there. We need to eliminate that negative 9 by division, because we are multiplying by a negative 9, we divide. So negative 18 divided by negative 9 is a positive 2. And now we are taking up another notch. Right here, we are taking it up another notch. I hope that this one is, let me look at number 17. Oh, those are the email. Let's go. Any suggestion for number 17? I need a suggestion before I begin. But I'm not going to wait for you forever. No suggestion, I'm giving you a few seconds here. So, Mr. TTR, take a second look at the problem and then say it again. Right, so Mr. TTR, take a second look and say it again. Alright, so let's see what you say now. Right, we're going to add m to both sides because if you have a minus 10m here and you subtract 10m from both sides, you're going to get a negative 7m here and you're going to have a negative 17m here. And where you are will be worse than where you started because you're saying what we should do with 10m in order to eliminate that 10m. So we're going to add 10m. When we add 10m here, the 10m is going to be eliminated, and on the left-hand side, we're going to have 3m plus 10m, and that is going to give us 13m. Any suggestion as to what we'll do so that we don't take 15 steps to solve the problem? Alright, this is going to take longer than I imagined. So, whilst adding 10m to both sides, we will subtract 5 from both sides. Why are we doing that? We are doing that in order that all of the terms that contain the unknown will be on the left-hand side. And everything else will be on the right. So all terms in m to the left and everything else to the right. So we subtract 5 from both sides. And then we have our 31 minus 5 is 26. And finally, what is m equal to? We cannot spend an hour on this because we have done that at least 10 times since we've started. So we have 13m is equal to 26. We'll eliminate that 13 by dividing by 13. And then we'll also divide by 13 on the right hand side. So m is equal to 2. One step. P is equal to what? Yes, one step. What is P equal to? Are you sure that it is not 0.8? Are you sure that it is 8? Surely it is 8. Right. But because of the presence of the point, I'm going to put it right here. Because of the presence of the point, some students will say 0.8. So we have 1.6 over 0.2. When we were in primary school, we used to learn on mechanics. Yes, we used to learn some mechanics that go like this. Do one decimal place here, you also do one in the denominator. So 1.6 divided by 0.2 is actually 16 divided by 2. And that will give us 8. So 8 is correct. Alright, so we are taking it up now a bit further. We are taking it up a bit further. What do we do here? Any suggestion? Because whatever you say to do in the first take, I will do something different in the second take. So what do you say that we should do in the first take? Any suggestion? I like that. Minus 3 on both sides. Minus 3 on both sides. Then minus 1. Divide by 3 on both sides. Now students, when you have a problem with parentheses, as a general rule, you should not attempt to eliminate this 3 by division. But in this case, it is safe to do so because the right hand side is also a multiple of 3. So if you divide this side by 3, why can we do that? Because the presence of the 3 here is saying that 3 is being multiplied by this. So 3 is multiplying the contents of the parentheses that contain, that what? Has the what? The unknown. So the unknown is within those parentheses that is being multiplied by 3. So we can eliminate 3 by division. When we divide 3 by division, we get t plus 1 is equal to, of course, because we divided by 3 on the left-hand side, we need to divide by 3 on the right-hand side also. So the result there is 2. And finally, t is equal to 2 minus 1, which is equal to 1. And as I said before, as a general rule, we should, when we have parentheses, we should not be hasty to divide. But in this case, this problem facilitates the division by 3. So that's a perfectly legitimate step. With or without, it would have been a legitimate step. But I'm talking about the entire, what we call terms that are there that might turn out to be somewhat cumbersome and somewhat tedious. However, now we will take the general approach, which is to expand the brackets. So we expand by saying what? 3 times t is 3t, and 3 times 1 is 3. And what do we do next? 3t will subtract t from both, subtract 3, from both sides, and we'll get that. And then t is also equal to 1. So irrespective of what we do, the result is 1, but the general approach would have been to expand the brackets. The general approach would have been to expand the brackets. So number 23 is, as a matter of fact, about expanding the brackets, and also this symbol, the less than or equal to symbol that we have right there. Right, so we have the less than or equal to sign symbol right there. Now, that less than or equal sign, less than or equal to sign, makes it an inequality. And of course, we're going to do the same thing that we have done to the equation. We're going to do that with the inequality. Yes, whatever we have done to the equation, we're going to do that also with the inequality. However, there are some exceptions, and we'll see those exceptions as we go along. Okay, I don't know what that is. All right, so let's, my computer screen is showing a little bit down there. Page Hunter should tell you why I'm always on my computer. Page Hunter. All right. All right, no problem. Let's continue. So we'll expand. Let's expand. 3b, 3 times negative 2 minus 6. Then we go to here, minus 20b minus 35 is less than or equal to negative 7. And of course, we're going to take all of those b's on one side, and we'll have what? 3b minus 20b, and on the other side we have negative 7. Of course, we are going to eliminate the negative 6 from this side, a positive 6. We are going to eliminate the 35 from this side, a positive 35. And the result will be what? 3b minus 20b is negative 17b. Negative 17b is less than or equal 34. That's what we will get. I'm going to write it out a little bit more so it might not interfere with when this comes down. Negative 17b. So what we have done, expanded the brackets, and we cause the unknowns, all terms containing the unknowns to remain on the left hand side. Everything else we stash those away to the right. So we have negative 17b, because I'm going to write another step, is less than or equal to 34. Implies that, this is the last part now, because we can use the implication sign. Implies that when we are finished, what will happen? Of course, you know that we're going to be dividing by that negative 17. But when we divide an inequality by a negative quantity, the inequality sign will change. Yes. When we divide an inequality by a negative sign, the inequality sign will change. Also, when we multiply the entire inequality by a negative sign, the inequality sign will also change. So while we are saying 34 divided by negative 17 is negative 2, we will have to say b is greater than or equal to negative 2, because we need to change that inequality sign around. So we'll have b is greater than or equal to negative 2. That is what we'll have right there. This is just doing another one. However, in this one, we will not change the inequality sign because we will be neither multiplying or dividing by any negative quantity. Let's go. We will apply the one that we say is general, because of course you see that we are multiplying by 4 here, and if you divide both sides by 4, that would have been totally legitimate. It's going to be a correct thing to do. Yes, it will be correct. So if you divide both sides here by a 4, that will still be correct. But it is going to cause the figures to be a little bit scary. So expanding the brackets will be better. And when we expand the brackets, what do you see? 5p is less than or equal to 4 9s, 36. Minus, and then 4 times negative p, negative 4p. Nice. What will be the next thing? Somebody please tell me what the next step of this one will be. Let's go. What the next step of that one will be. Nothing? There'll be there'll be no next time? All right, so no one to say what the next step will be. So I am going to say what the next step will be. We have another occurrence of the unknown right here on the other side, a minus 4p. What we will do, therefore, is to add 4p to both sides. When we add 4p to both sides, 5p plus 4p will be 9p. And this will be less than equal to 36. Why? Because the 4p, the negative 4p, would have been eliminated. And the next step will be to eliminate this 9. And because we are not dividing or multiplying by any negative quantity, it will be simply 9. It's simply the 9 is less than or equal to 4. Nine is less than or equal to 4 on that occasion. So we'll move on. We'll move on to this one, which is, of course, we are going to go up another level. Yes, we are going to go up another level. Let's see what happens. Okay. Now, as soon as someone sees this, what they say, cross multiply. No, we cannot cross multiply. We should not cross multiply because cross multiplication is not mathematics. Now you learn a new one. Cross multiplication is not mathematics. What's mathematics is eliminating these denominators. That's what we should do. And we will eliminate those denominators by multiplying by a single number that the 2 will go into and the 7 will go into without a remainder. So we are going to multiply the entire equation by a number that the 2 will divide into and the 7 will divide into without a remainder, and we are going to choose the smallest such number, and the smallest such number will turn out to be the LCM of 2 and 7. So my question is, what's the LCM of 2 and 7? And I get it before I finish asking. 14. And then the 14, I'm going to do something right here. We take the 14 and we multiply the terms of the equation. So let's go. The 14 will multiply the h over 2 first. I'm writing that. Let me see if it is outside of the patch. It's a little bit touching it, so let's go a little bit down. So h over 2 multiplied by 14. How do we do that? Of course, 14 is a fraction. Right. Also, 14 is a fraction with a denominator of 1. So we say what? 2 into 2, 1, and 2 into 14 is 7. So h times 7 will be what? 7h. So h times 7 will be 7h. What about the next one? No doubt. Do by analogy. H over, I'm going to put it down a little bit lower. H over 7 multiplied by 14. What will happen? The 7 will go into the 14 to be 2. And h times 2 is 2h. So you can do it on the spot by saying 2 into 14 is 7. 7 times h is 7h. 7 into 14 is 2. 2 times h is 2h, and that is equal to 10. I'm going to write it as 10. And you tell me what's wrong right there. Somebody please tell me what's wrong right there. There's something wrong with this. I'm just making a common mistake that students make. Students generally make that mistake in an examination, on tests, on homework. Yes. It should be 140 because also the 10 must be multiplied by the 14. 140. So 7h minus 2h is 5h is equal to 240. 140. And then we do what? 140 divided by 5. And of course, 5 and 2 are converse number. So 5 and 2 are converse numbers. So if somebody's say to you, what is 140 divided by 5? You just say, what is 14 multiplied by 2? So 14 multiplied by 2 is 28. So 140 divided by 5 is also 28. Right. So what? The 5 and 2 are converse number. So if something is too difficult to divide by 5, you multiply by 2 and make the relevant adjustment. You try that, it will work. And that's mathematics. We have mathematics. Right? If you have this book, you'll be able to make what? Thousands of calculations in your brain. We teach you how to work on the basis that 5 and 2 are converse numbers, but 25 and 4 are converse numbers, 125 and 8 are converse numbers, 265 and 25 are converse numbers. So you can do that. So both the numbers have a h. H is not a variable there. Of course, when you are finished, you see that h has a fixed value. Right. So in that case, h is not a variable. You must stop following the American people them and talk them stuff there. Or do you call something variable when it does not change? Or you don't know if it is subject to change? It can only be a variable if it changes or it is subject to change. All right, so let us continue. What are converse numbers? All right, let me give you an idea. What are converse numbers? We have a problem there. 2,480 to multiply by 25. Now, because 25 and 4 are converse numbers, if they give you something to multiply by 25, if you divide it by 4, you can arrive at the answer quickly. So 24 divided by 4 is 6. 8 divided by 4 is 2. So the answer is that. When you multiply that by 25, that's the result that you're going to get. So converse numbers are numbers that you can use in place of each other when you are making a calculation. So if you are required to multiply by 25, this is hard as it is to multiply by 25. But it's a lot easier to divide by 4. So if you divide by 4 and then put on 2 more zeros, you'll get the same answer as if you multiply by 25. Yes. Now we have a lot of mathematics. We have a lot of mathematics that we can use. And of course, they are present in this book. This book has what? Maybe 140 pages of mathematics and the exercises. Yes, 140 pages, let me see. 140 pages of mathematics and the exercises. And of course, about 62 pages of answers. Yes, 62 pages of answers. It's a nice book to have. All right, let's continue. And of course, we did this problem by making use of the fact that 2 and 5 are converse numbers. So we are required to divide 140 by 5. But it's easier to multiply 14 by 2 to give you 28. And of course, if you divide 140 by 5, you're going to get 28. So the 5 and the 2 right there are shown to be converse numbers. 5 and 2 are converse numbers, and the 25 and 4 are converse numbers. So what do we do with this now? We need to multiply this entire equation by a single number that 3, 4, and 5 can divide into without a remainder, and of course, should be the smallest possible such number. And what is that smallest number? What is that smallest number? 5 can go into it, 3 can go into it, 4 can go into it without leaving a remainder. That means it is divisible by 3, 4, and 5. And we want the smallest such number. Oh, 60. So let's use our 60. And what do we say? 3 into 60 is 20, and 20 times m is 20m. 4 into 60 is 15, and 15 times m is 15m. We cannot leave the negative 10, we need to multiply by 60, negative 600. Greater than or equal to We have to multiply the 13 by the 60. What do we get when we multiply 13 by 6? My guess is that it is 78, so put a 0, 780. Of course, it will be, what did we say? Yes, 13 times 6. Of course, 13 times 5 is 65. Add 13 to 65, you'll get your 78. Then 5 into 60 is 12. 12 times m is 12m. So what do? We'll accumulate all of the m's on the left hand. Some of the students would have fallen asleep already. And this positive 12m will be eliminated from that side. 780 goes back, and we will eliminate the 600 from the negative 600 from that side. Lovely. And all of those together, I will do it quite easily by saying 15m minus 12m is 3m. And then put that with the 20m. So I'll get 23m easily right there. And then we'll put these together also. 0, 0. 8 with that 0 also. So 0 with 0. Then 0 with 8. Then 7 with 6. Right. Student, in the good old days, when we get a problem like that, we imagine that it will work out easy. So if we get a problem saying 1,380 divided by 23 is what? We would think that it is going to work out simple. We think that it's a simple problem. And we think that it would give us a rounded figure. And 99.99% of the time we would have been correct. Yes. 99.99% of the time we would have been correct. Because that's the olden days. Mathematicians of the olden days, they used to do a lot of sensible things. Now you look into a textbook and you see a number divided by the other, then when they are through, they have 15 decimal places. Unnecessarily. Now, another thing that you need to be mindful of, I see the answer coming up on the board there, is that, yes, the answer is there already. It's a rounded figure, it's a simple figure also. Right, so what we will do when we are required to divide this, because we want to get the answer, but we don't want to go through the rigmarole, because we know that we already have it in our minds that the answer is simple. So what we'll do is, we are going to try to see which number will work quite easily to give with the 3 to give the 8. And guess that is the number. That's what we'll do. Which number works with the 3 to give the 8? 3 1s 3, 3 2 6, 3 3 is 9, 3 4 is 12, 3 5 15, 3 6 is 18. Because 3 6 is 18, we are guessing that it is 6 times. Because this ends with an 8. So the 8 will come about by multiplying the 3 by 6. So we are settled at 6. But we just don't settle at 6. We try it out. By saying what? We take the 23 and we're going to multiply it by 6. 6 3 is 18. Put the 8 and carry 1. 6 2 is 12 plus 1 is 13, and we know that we are right. Therefore what? M is greater than or equal to 60, as somebody suggested already. So in those days we hardly use calculator. Only extreme cases we use calculator in. Right. And that's lovely. Wonder if I can do something on that side. Let me look into the problems and see what we have. I want to put 2 more up there. Let me see if I can put them there. We have number 31 and number 33. And I'm looking at the space right there. Number 31. Number 31. What do we say for number 31? 2 over x is equal to 2. Maybe I need to put it a little bit higher. Let me see if it's very low. It could be a little bit higher. Yes. Number 31. Although it's a one-step problem. 2 over x is equal to 2. Students, do not spend the entire time trying to solve that problem and trying to transpose. You know that 2 is divided by a number. So that when the number that you 2 divided by that number and the result is 2. So what number goes there? If you divide 2 by a particular number and the result is still 2, what number are you dividing by? So x must be equal to 1. So you don't have to go, you don't have to sail the 7 seas to end up with the correct answer for that one. Number 33. Five over x is less than 10 over 3. If it goes into the light, no, it doesn't go into it. 5 over x is less than or equal to 10 over 3. 5 over x is, let me see if it's less than or equal to, is less than 10 over 3. And when we are solving a problem like this, students, we did something similar to that in our transposition. That's nice. That's nice. That's nice, man. Everything you do, I say nice. Alright, so let's take a look at that. Now, if you notice with that problem, the x is in the denominator. Right, the x is in the denominator. The x is in the denominator. Alright. The x is in the denominator. So it would be good if we use a strategy that we use in transposition of formulae and reciprocate both sides. But when we reciprocate both sides, we'll have to change the inequality sign. We'll have to change the inequality sign. So x is greater than 3 over 10 if it's multiplied by 5 because we're dividing by 5. So there you got your what? Your 3 over 2. I'm going to do it again. So it's 5 over x is less than 10 over 3. Let's go. Of course, what we said is that since the unknown is in the denominator, we could do x over 5. And then when we do that, 3 over 10. When we do that, we'll have to change the inequality sign to the next one. And then what do we do after that? X over 5. I'm going to just about that a little bit. X over 5. 3 over, we're eliminating this 5 by multiplication. Eliminate the 5 by multiplication. So we have x is greater than 3 over 10 times 5. And of course, the 5 will cancel. We have x is greater than 5 into 5 is 1 and 5 into 10 is 2. So 3 over 2. And that's the final part for that. Now, we have maybe 3 problems left. 35, 37, and 39. That's nice. And we'll begin over here. All right. Okay, so let's continue. Number 35. What do we say about number 35? 7 over 4x minus 16 over 9x is greater than or equal to 2. Once bitten, twice shy. So let's go. What do we say about that? We need to multiply by what? What do we need to multiply by? Sure. What do we need to multiply by? Take too long. 4 9 36. So what do we say now? 4 into 36 is 9. 9 times 7 is 63. 9 into 36 is 4. 4 times 16 . 4 times 16 . Is that okay? That's nice, man. Is that okay? All right. No answer? All right, I'll give my answer. It should really be 72. Because we need to multiply the 36 by 2 also. Let's continue. 63x minus 64x will give us a negative x greater than or equal to 72. Of course, in order to make x the subject of the formula or to find the value of x, as in the case of solving an equation, which we are doing now, what do we say? X is less than or equal to negative 72. Why? Because we are either, since it's just a coefficient of 1, whether we divide by negative 1 or multiply by negative 1, the result is going to be the same. It's just that when we multiply or divide an inequality by a negative number, the inequality sign will change. As we have it right there. Your favorite is coming up, number 37. Y minus 2, is it? No, y plus 2. Y plus 2 over 6 minus y minus 2 over 7 is equal to 2. Y plus 2 over 6 minus y minus 2 over 7 is equal to 2. And of course, I'm going to multiply this. What do we multiply this by? We will multiply that by the lowest such number that 6 and 7 will divide into without a remainder, and that turns out to be 42. And this is what some students will do. That's not what I would do, but this is what some students will do. 6 into 42 is 7. So they take the 7, 6 into 42 is 7, so they take the 7 and multiply this. 7 times y is 7y, and 7 times 2 is 14. Nice. Then they go to the next one. 7 into 42. 7 into 42 is 6. So they'll do the same thing. 6 times y is 6y, and 6 times 2 is 12. Equal to 2. So in this case, the students would have made some horrendous mistakes. The first one that is obvious to you is this one, that you need to multiply the 2 by 42 also. That will give you 84. So that will give you 84. That's fine. But for some reason, some students will not be able to see the next mistake that is inside there. So while glancing on this, I'm going to do the right thing. No. 37. So we're going to have y plus 2 over 6. I'm going to use a new marker to write it. I'm going to use a new marker to write it. Minus y minus 2 over 7 is equal to 2. And what I said that we should do, multiply by 42, so we are doing the same thing. Everything is the same as before, but this is a big difference, and it makes a big difference. So we're going to say 6 into 42 is 7 times. So we say 7y plus 2 minus 7 into 42, 6 times. y minus 2. And that's equal to, not making the same mistake again, 42 times 2, 84. Nice. Then we proceed to expand the brackets. Seven times y, 7y, 14, 6y. Negative times negative is positive. So there it is, students. Look here. See the negative 12? See the positive 12? Correct. Because negative 6 times negative 2 is a positive 12. And the big mistake that students make in circumstances like this is that you do not maintain that the negative sign that we have here is pertaining to the two terms. So it is pertaining to the y and it is pertaining to the negative 2. That's the mistake you are saying, that it's not pertaining to both. That's the mistake that students generally make. And the CXC examiners, it's not that they are tricking you, but they put a problem for you to solve, and because of your ignorance or failure to exercise presence of mind, then the answer is wrong. But it's going to be right on this occasion. So what do we say? 7y minus 6y is equal to 84. Do what with 84? Minus what? 84 minus 14 minus 12. So 7y minus 6y is just merely y. 84 minus 14, that is 70. And from that 70, you may take 12. And that's your final answer. 39. I'm sure that you'd want to get a little bit out of the next one. Yes, I'm sure that you'd want to get a little bit out of the next topic. This one, you don't have to use the brackets because 2y minus 3 over 2 is equal to 4 minus 5y over 3, and that you're going to multiply by 6. So when you multiply, you're going to get what? 2 into 6 is 3. You can do it here because we don't have a second bracket and we don't have that ambiguity with the negative sign to handle. So we may say 2 into 6 is 3. 3 times 2y, 6y, minus 3 times 3 is 9. And that is equal to 3 into 6 is 2, 4 2s 8, and 5 2s 10. Right. And of course, you can sort that out in like some of the problems that we have done earlier on. 6y, you want to add the 10y, so 16y will be there, is equal to 17 when we add 9 to both sides. So y is equal to 17 over 16. And that is what we make of the application topic of solution of linear equation. It's merely an application topic. Why is this merely a application topic? It's merely an application topic because all of the concepts that we use in solving the problems in this topic are concepts that we just brought over from transpositional formulae. And of course, what I've done half of the homework for you by doing what? The odd numbers. So I've completed the odd numbers of the homework section. So you're going to go to the homework section and you're going to do the even numbers. Nice. And the next tutorial, Sunday tutorial, we may have some of these to solve in the tutorial. We may have some transposition to do in the tutorial. We may have some quadratic equations to do in the tutorial. So the tutorial is getting warmer and warmer as we solve all of the problems that we need to solve. I dare say that the other visuals that we have on TikTok, the students are not watching them. So when we go to factorize something like a difference of 2 squares, everybody is. And I think that you're not reading your instructional manual either. Because when it comes to the instructional manual, I do not skip over. So if it is that we're going to do solution of what? Linear equation, we do solution of linear equation as soon as we are finished with transposition. And as soon as we finish with the linear equation, we move on to quadratic equation. And as soon as we finish with quadratic, we go on to simultaneous. And as soon as we move on to simultaneous, we go to simultaneous linear and quadratic, linear and nonlinear. That gives rise to a quadratic equation. So let's go to our quadratic equation and let us have some fun. All right, so let us take it over here because I'm not in a haste to delete that side. So we're going to be solving quadratic equations. And what I said before applies. I am not going to teach you how to solve a quadratic equation. Why? Because for the intents and purposes of these exercises, you're going to solve a quadratic equation by factorization. Come on, students, factorization. We just finished factorization. So much so that the other visuals are not even finished going up on TikTok. Right, so we have the quadratic equations, and I'm not going to teach you how to solve them. There are 2 concepts that you need in order to solve a quadratic equation. You need to be able to factorize a trinomial and other things, maybe a difference of 2 squares. You need to be able to factorize whatever you need to be able to factorize up to the standard of a trinomial. And you need to know how to solve an equation. So if you have to learn how to solve an equation, we cannot teach you how to solve an equation when we are doing quadratic equation. Because you know how to solve an equation already. And you know the concepts of solving an equation is transposition that you did in transposition of formulae already. So you are ready to go. As someone say, you are good to go. All right. So let's look at this. I'm going to use maybe a simple one. X squared minus 2x minus 35 is equal to 0. That's a trinomial, students. Can anybody give me the factors of that trinomial? Let's go. May I have that? The factors of that trinomial? 1, 3. Let's go. So what are the factors? I am waiting for the factors, and I'm going to see the factors as soon as I look on the screen. No? Well, I'm not waiting any longer. The two numbers multiply to give a negative 35, and when we add them, we get a negative 2. X minus 7, x plus 5. X minus 7, x plus 5. Students, it is in this initial phase of the solution of quadratic equation that you need to pay the most attention. You can stay there saying that you don't know after I've put up so many things to factorize and so many other visuals telling you how to factorize. And we have a trinomial here. I'm going to look at the section in with trinomials inside here. Trinomial. In the introductory part of trinomial, we had 7 problems in the introductory part. In one of the class exercise, we have 8. In the next one, we had 7. In one of the homework section, we have 20. In the other section, we have 24. So we have 7 in the introduction. In the class exercises, we have 7 and we have 8. And for the homework, we have 20 and we have 14. And when I put up a trinomial on the board, some of you going like you don't know how to do it. You don't know that you have a real examination in less than 8 months' time? Some of you. Some of you have the examination. Some do not have the examination. Look at that. This is a class that you can join on TikTok without paying. And we have 12 students joining at the moment. Yes. Yes. It's a class, it's mathematics, you don't have to pay for it. Next year, let me tell you some of the teachers who will believe in Jamaica. Not the Jamaica, but the system. You have Mr. McLennan, you have Mr. James, and you have Mr. Virgo. Mr. James and Mr. Virgo surely not going to return to a classroom in September. So you all have to make up your minds what you want. Yes, make up your mind what you want. See that? 11 students joining a class that students don't have to pay for. So that shows you the interest that we have in education in this country. So if you want to know the interest that we have in education in this country, a free mathematics class on TikTok with 11 students in it. And of the 11, how many are you serious about this thing? All right, so I'm going to use the 20 minutes that we have left, little over 20 minutes that we have left, sensibly, so that when we return on Thursday, we can finish up that and maybe do something in the solution of simultaneous equation. Let's go. So here, what do we notice? We notice that when we factorize, we have this and we have this. What is the relationship between the contents of the two pairs of brackets. What's the relationship with the x minus 7 and the x plus 5? How are they related in this expression? How are x minus 7 and x plus 5 related in this expression? So that's your question. So no one knows? Alright, fine. They are related by multiplication. So this is being multiplied by this, and the result is 0. So this times this equals 0. So what do we know? If two numbers, two expressions, two symbols are being multiplied and the result is 0, either one is 0 or both of them are equal to 0. Now, in our minds, that's how we need to be able to do this. If x minus 7 is equal to 0, we can see that what we need to do is add 7 to both sides. So in one case, x is equal to 7. And in the other case, when x plus 5 is equal to 0, we need to subtract 5 from both sides. So x is equal to negative 5. Like that. If it gets a little bit more sophisticated, we are still able to handle it, because we can solve a linear equation. So if we have then, instead of that, 3x minus 8, 5x plus 7 equals 0, what do we do? Because we are expected to write from this factorized form, x is equal to something. So if this is equal to 0, we will, you know that we eliminate the one that is least related to the proposed subject. So we need to eliminate the negative 8 and we need to eliminate the 3. So when we eliminate the negative 8, we're going to eliminate the negative 8 by adding 8. And then we're going to eliminate the 3 by dividing by 3. And in this case, we will eliminate the plus 7 by subtracting 7. And then we'll eliminate the 5 by dividing by 5. And that will be your two figures. So I'm going to leave them right there, and I'm going to place your exercise on the board. And we're going to execute that. Number 1, what I want you to do, when you see the expression written in the factorized form, I want you to write the answer down like that. And like this one, you see the answer in the factorized form, I want you to write the answer down like that. So I'm going to put 8 of them on the board, and let's see the answers in a flash. I know that I didn't close the bracket. I'm going to put it down somewhere so that that will remain on the board. Let's go. The first one. What is x equal to? so negative 7 over 4 is 1, and I didn't see the other one. Okay, of course, so let's go. We have to eliminate this negative 5 by adding 5, so a plus 5, and then we divide by 2. Next one, we need to eliminate this positive 7 by subtracting 7, and then we divide by 4. This one, we need to eliminate this positive 2 by subtracting 2, and that's all there is to it. Then here, we need to eliminate this positive 5 by subtracting 5, and then eliminate that 3 by dividing by 3. In this case, what do? We eliminate the negative 1 by adding 1, and then divide by 6. And then the other one is the same thing. Notice that although the factors are the same, we did not just write one occurrence of 1/6. We wrote it twice. Why do we write it twice? Because a quadratic equation must have two what we call roots. Two values that satisfy a quadratic equation. So we have to have two values or two roots. In this case, we say that the equation has repeated roots or equal roots, and that will just be fine. What about this one now? I'm giving you a chance at this one. A few seconds. Let's go. Okay, great. So x is equal to 9 and negative 7. We just need to eliminate this negative 9 by adding 9, so we get a positive 9, and we just need to eliminate this 7, positive 7 by subtracting 7, and we have a negative 7 right there. So let's go for this one. Let's see what you will make of it. Okay, so let's go into it. In that case, let's put it over here. 2x (3x minus 7) is equal to 0. Right. So 2x, 3x minus 7 is equal to 0. So in that case, there are two things that we are multiplying. We are multiplying this by this, and the result is 0. So in that case, we're going to say that let's say this one is equal to 0. If this one is equal to 0, we will eliminate the 7 first. This negative 7, we'll eliminate that by adding 7, and then dividing by 3. What about this part? We're saying that 2x is equal to 0. So if 2 times x is equal to 0, since 2 cannot be equal to 0, it must be that x is equal to 0. So x is equal to 0 is one solution. And if we solve this one by analogy, then x is equal to 0 in this one also. And of course, you can see that we need to eliminate this positive 5 by subtracting 5. And in this particular case, what will happen? Zero and 7 over 3. We have done that one already. So let's continue with this one. We eliminate this 5 by addition, and then put it over some more. We eliminate this negative 5 here by addition, so we have a positive 5 there. And then we divide by 4. In the next case, we'll eliminate this 5 by subtraction, so we'll get a negative 5, and then we'll divide by 4. So this is positive or negative 5 over 4. Finally, what do we say about this one? Eight. We'll eliminate this negative 8 by adding 8, that's all. And then in the next case, we'll eliminate the negative 11 by adding 11, and then we'll eliminate the 4 by dividing by 4. And that's all there is to it. Okay. So, we'll continue the solution of quadratic equation on Thursday. Of course, we're going to finish the exercise because we have what? 3 exercises. We have 1, 2, and then I'm going to do a portion of the exercise. So I'm going to do a part of the exercise, the homework exercise. So I'm going to do the exercise 1, the exercise 2, well, this is exercise 3 and 4, because this is exercise 1. So I'm going to do the next 2 exercises, and then I'm going to do a portion of or a part of your homework on Thursday. And then that's it for it. And then great chance we'll be able to move on to the solution of simultaneous equations. Yes, I would like to get an hour into that. So Thursday is going to be a very interesting class. Now, students, even being such a great distance away, I can tell that the students don't go through the instructional manuals. You don't look at your tutorials. You don't look at the TikTok videos. If anyone does, it's going to be out of the class of 11, maybe 3. But that's fine. Yes. Right. I'm not going to discourage you. I'm not going to encourage you one way or the other. What I'll do when I get here, I will be as clear as crystal on the board. 90% of my work is already done because you have the instructional manual with everything that I intend to teach. And you have instructional videos on the YouTube channel. And then on the TikTok, I put in the other visuals for you again. Then I have your tutorials for you already. Then for the homework, for the examination final practice, I have your paper 2 solutions. I have your paper 1 practice, and in your paper 2 solutions, I have included also paper 3. So you have paper 3 inside here for those students who are not doing the SBA. So that is how it manifests itself. No, not for the CXCC sake, I don't have face-to-face class. Students, make the best of what you have. Students, make the best of what you have. Students, make the best of what you have. Next week, next year, when I come onto TikTok, I'm not going to be conversing with you at all, you know. So I'll get that clear. So next year, when I get onto TikTok, if I come on. So next year, if I choose to get onto TikTok next year, you will not be, when you type something inside here, it's not me you're talking to. I'm just going to be on the board doing what I'm supposed to do. When I'm finished, me just finish class and gone. That is how it is going to be next year. So be delighted that I'm conversing with you at the moment. You can see that I'm well up in age now. Well, if you don't see, then you can take a tip. I've been teaching from 1989. This is 2024. So work that out. This is my 35th year. It's time for me to throw in the towel. Thank you very much. The one who says, enjoy your night. You have a very restful and peaceful night also. Let me tell you something about the examination and speed. If we do one topic, the exam date is going to be the same. If we do 10 topics, the date of the examination will be the same. If we do no topic at all, the date of the exam will be the same. If you get ill and you cannot attend class, the date of the examination is going to be the same. You know what that means? That means you have to do whatever it takes. You all have access to 7 instructional manuals. You have access to 5,000 audiovisuals. You have access to 2 sets of tutorials that you cannot finish those books in 1 year. You have your paper 1 solution and you have your paper 2 solution and your paper 1 practice. Everything is cut out to your hand. Students, if you don't take advantage of what is going on right now, no go feel it. Where in the world you're going to go and the teacher writes 7 instructional manuals for you know? The more you get is the less you do. Where you going to go where the teacher have two tutorials set a book for you to practice for the whole year and can't finish? Where else are you going to go where the student have so many resources for one CXE exam? 5,000 audiovisual, 7 instructional manual, 2 sets of tutorials, paper 1 practice, paper 2 solution. Where else in the world are you going to have access to go feel if you not take advantage, you know? We just have 9 left because some are already gone. Look when Jamaica education system realized that the Richard James Mathematics resources good for them. Wait until they discover that. Look how much it go cost them. Look how much they're going to need it, you know. They're going to come for it. And when they come for the mathematics resources, look how much it go cost in Jamaica. Look how much it go cost the government for. Because we're going to make them know that they get it for free. Bro, God get it for free. What the pastor one name? I'm going to tell you all who get it for a few of you left, maybe 9 or 10. Andrew Holness get it for nothing at all and not take it. I'm going to tell you who else get it and don't take it. I name again. Ronald Thwaites get it for nothing and not take it. This one name will come back again. Damian Crawford get it for nothing and not take it. Fayeval Williams, ignore it. Cruel Greed, him ignore it too. All I'm going to do is just continue writing. Because I know the day is going to come and I'm going to go come after Richard James Mathematics resources. And I'm not going to believe how much it will cost the government. Thank you all for joining. Thank you for sharing. Thank you for participating. Thank you for telling others, inviting others to come. The newcomers, thank you for following Richard James Mathematics Resources on TikTok. The old timers, people who are soldiering along, students who are ever here, ever present from the beginning of September. A great thank you to you also. And it's time for me to take my leave until Thursday. So you all have a very peaceful and restful night. All right. So you know that's the end of it. Thank you very much.